Good day, everyone. Welcome to Ice Cream Maths Academy, where numbers and variables actually mean mastery. Today, we are going to be looking at a very fast method of finding the derivative or differentiating Euler functions. Yes, let's get started. Now, we all know that if y is equal to e raised to the power of x, this is the Euler function. Yes, that the y all over the x will still give e raised to the power of x. Yes, so when you differentiate e raised to the power of x, it gives e raised to the power of x. So when you have e raised to the power of any function outside x, it becomes a function of function. Example, if you have y is equal to e raised to the power of tan x, here you can see that tan x has actually taken the position of x. So this is a function of Euler function, just like having the bag inside another bag. Now we're going to be differentiating functions of functions of Euler function using a very fast method. Okay, now example 1. Now find the derivative of the following functions. Yes, find the derivative of the following functions. Now A, we have y is equal to e raised to the power of tan x. Yes. B, we have y is equal to e raised to the power of sine 2x. Yes. C, we have y is equal to e raised to the power of ln x. D, we have y is equal to e raised to the power of 10x raised to the power of 4. Yes, so here we have to find the derivative. Yes, finding the derivatives means finding the y all over the x. That's changing y over changing x. Now solution. Now if y is equal to e raised to the power of tan x, the y all over the x. Now remember we said when you differentiate e power x, it gives you e power x. So here we are differentiating e raised to the power of tan x. So you differentiate this, it gives e raised to the power of tan x, then you times it, you multiply it by the derivative of this function. And of course when you differentiate tan x, it gives sec squared x. So it means the y all over the x will be equal to, we have sec squared x, then e raised to the power of tan x. That is the y all over the x. Yes. Now let's look at B. Let's look at question B. Now B, we have y is equal to e raised to the power of sine 2x. Yes. Now the y all over the x, when you differentiate e power sine 2x, it gives e raised to the power of sine 2x. Then you multiply it by the derivative of this function. That is the derivative of sine 2x. And when you differentiate sine 2x, it gives 2 cos 2x. It means the y all over the x will be equal to, we have 2 cos 2x, then e raised to the power of sine 2x. That's the y all over the x. Now let's see question C. Now question C, we have y is equal to e raised to the power of ln x. Yes, e raised to the power of ln x. Now the y all over the x, when you differentiate e power ln x, it gives you e raised to the power of ln x. Then you times it by the derivative of this function. Yes, that is actually taking the position of x. So when you differentiate ln x, it gives you 1 all over x. So it means the y all over the x will be equal to 1 all over x, then e raised to the power of ln x. That's the y. So this is actually a very short, fast method of finding the derivative of functions of Euler functions. Thank you so much for listening, and God bless you.